Good day. Our topic is about solving exponential inequalities. But before anything else, we are going to discuss first the property of exponential inequalities. Property number 1. It states that if b is greater than 1, then the exponential function y is equals to b to the power of x is increasing for all x. This means that b to the power of x less than b to the power of y if and only if x less than y. Example, 3 to the power of x. This 3 here is our base, which is represented with small letter b. So b is equals to 3. And we all know that 3 is greater than 1. Therefore, b is greater than 1. Or b, which is equals to 3, is greater than 1. In this case, the direction of our inequality will be retained. Property number 2. It states that if b is greater than 0 but less than 1, then the exponential function y is equals to b to the power of x is decreasing for all x. This means that b to the power of x greater than b to the power of y if and only if x less than y. Example, 1/3 to the power of x. This 1/3 here is our base. So b is equals to 1/3, or in decimal form, that is 0.33 repeatedly. We all know that this 1/3 is less than 1. We also know that this 1/3 is greater than 0. Therefore, b, which is equals to 1/3, is greater than 0 but less than 1. In this case, the direction of our inequality will be reversed. So that's all about property of exponential inequalities. Now let's proceed with example. Our first example is solving the inequality 3 to the power of x less than 9 to the power of x minus 2. So our given is 3 to the power of x less than 9 to the power of x minus 2. Our main goal here is to look for a base which are of the same value. So to do this, we need to factor the base. We all know that our base are 3 and 9, which are of the different numbers. So we are going to make it of the same numbers. So factoring 3, that is 3 times 1. For 9, that is 3 times 3. So as we can observe, we have common factor here, which is 3. And we are going to use these numbers to represent it in an exponential form. So for the base 3, the exponential form is 3 to the power of 1, or that is just equals to 3. For the base 9, our exponential form is 3 to the power of 2, or that is also equals to this form. So they are just the same. Now, let's proceed with the solution. Again, our problem is 3 to the power of x less than 9 to the power of x minus 2. So the exponential form of this 3 is 3. And we are going to copy the exponent x together with the inequality. And the exponential form of 9 is 3 to the power of 2. Then we're going to copy the exponent, which is x minus 5. So after this one, we are still going to copy the numbers, which is 3 to the power of x, together with the inequality and this number. But for our exponent, we are going to multiply it, or we are going to distribute it to the inside expression, which is x minus 2. So as a result, that would be 2 times x is equals to 2x. Then 2 times negative 2 is equals to negative 4. As we can observe, our base are of the same numbers already. So since the base is 3 and is also greater than 1, then the direction of our inequality is retained. Now, to proceed with, we are going to copy this x together with the inequality, which is retained, and also the exponent in our right side, which is 2x minus 4, so that we can solve for x. To do it, we need to apply the subtraction and division rule. So in that given inequality, to solve for x, we need to subtract x in our left side. Since we are subtracting x in our left side, we are also going to subtract x in our right side. Then we have also number which is negative 4. Applying the addition rule, we need to add 4 in our right side. Since we are adding 4 in our right side, we are also going to add 4 in our left side. So to compute, x minus x is equals to 0. Negative 4 plus 4 is equals to 0. So the remaining inequality is 4. Copy the inequality symbol, copy the 2x, and copy the negative x. So as we are going to see on that given inequality, we still have like terms, which is 2x and x. So we're going to solve for that. That would become x. Then copy the inequality and also the number 4. And that is our final answer. So x is greater than 4. So the solution set for this is 4 to positive infinity. But this 4 is not part of the solution. Next, let's move on with example number 2. Solve the inequality 1 over 10 to the power of x plus 5 greater than or equals to 1 over 100 to the power of 3x. So given again, that is 1 over 10 to the power of x plus 5 greater than or equals to 1 over 100 to the power of 3x. So our main goal here is to look for a number that would make our base of the same value. So to do it, we need to factor the base. So our base here are 1 over 10 and 1 over 100. So the factor of 1 over 10 is 1 over 10 times 1. And the factor of 1 over 100 is 1 over 10 times 1 over 10. Expressing this, We all know that the common factor between these two numbers is 1 over 10. And expressing this into exponential form, we have 1 over 10 to the power of 1, or just equals to 1 over 10. And that is for the base, which is 1 over 10. And for the base, which is 1 over 100, its exponential form is 1 over 10 to the power of 2. Now, let's proceed with the solution. Again, our problem is 1 over 10 to the power of x plus 5 greater than or equals to 1 over 100 to the power of 3x. So the exponential form of 1 over 10 is 1 over 10. And we're going to copy the exponent, which is x plus 5, together with the inequality. And the exponential form of 1 over 100 is 1 over 10 to the power of 2. Then we are going to copy the exponent, which is 3x. Then after that one, we are going to copy again these numbers, 1 over 10, together with its exponent and its inequality. And in this part here, we need to multiply our exponents, which is 2 times 3x. So the resulting value is 6x. So as you can observe, we already have the same base, which is 1 over 10. So since the base is 1 over 10, which is less than 1, then the direction of our inequality will be reversed. Okay. Now, again, we are going to copy x plus 5. Then, our inequality, which is greater than or equal to, will be reversed. And that would become less than or equal to. Then, in our right side, we are going to copy 6x. So after this one, we can now solve for x. So in solving this, we need to follow the subtraction rule. So that would become minus x. Since we are subtracting x in our left side, we're also going to subtract x in our right side. Solving with it, that would be x minus x is equals to 0. So the remaining values are 5 together with the inequality, and 6x minus x is equals to 5x. Since our number here still have coefficient, which is 5, we are going to apply the division rule, in which we are going to divide both sides by 5. So that would be 5 divided by 5 times x. Copy the inequality. Then in our left side, 5 divided by 5. So the resulting answers will be 5 divided by 5 is equals to 1 times x is just equals to x. Then copy the inequality. Then on our left side, 5 divided by 5 is equals to 1. And that is our final answer. So x is greater than 1 or, oh no, x is greater than or equals to 1. So the solution set for this is 1 to positive infinity, where 1 is part of our solution. So that is all about solving exponential inequalities.